Hello friends, this video on P block elements part 14 is brought to you by examfear.com. No more fear from exam. Now we'll talk about another compound called diborane. So as I told, boron is nothing but the hydrides of boron, right? And this diborane is nothing but the simplest hydride of boron. This is B2S6. See, it has to be BS3, but BS3 is not stable because this boron is hungry of electrons, so it will form this dimer shape similar to AlCl3 and form B2H6. These are hydrogens. This is the shape of diborane, right? This is the angle 97 degrees, this is 100 degrees, this is 131 picometer the length, and this BH length is 119 picometer. Correct? It is colorless, it's a very foul smelling, it's a very toxic gas, and boiling point of 180 Kelvin. It's a very low boiling point, so colorless, foul smelling, toxic. If you see this is not forming a very complex cage-like structure, is it? No, right? It's just a BH3 molecule. This is the standalone molecule for this. And it is not having any tendency to form the hydrogen bond also, right? There is no cage-like structure. That's why if you see it is gas. Correct? You saw the boric acid. In boric acid, if you see, there was a structure, right? This is my B, there was OH here, there was OH here. I just trying to remember this is a BOH. Again, it was forming a hydrogen bond under another boric acid, if you see, right? This was a bond here. There was a bond here actually. So with the boric acid, there was a big cage-like structure, so it was solid. In this case, there is no cage-like structure. There is a standalone molecule for diborane, so it is colorless toxic gas. It is gas actually. That's the very reason it's gas. Toxic is because of some other reason, because it forms compound with blood, but it's gas because it is not a complex structure. Hope you understand that point. And it catches fire easily when it's exposed to air. The moment B2S6 reacts with water, oxygen, it gets B2O3, because I told it's very unstable, right? And it is readily hydrolyzed also. Hydrolysis, the moment I told hydrolyze, hydro means water, that means reaction with water, right? The hydrolysis itself means reaction with water. So you have B2S6 diborane, you react with water, it forms BOH3, boron hydroxides, and gives hydrogen gas, right? This is nothing but boric acid. So the moment diborane react with water, it gives boric acid easily. So if you want to prepare boric acid, you can do with the diborane itself. You have a diborane, just hydrolyze with water and you get boric acid. It also reacts with alkali to form metaborates and hydrogen gas. Let me write the reaction for it. Let's take this diborane. Let's react with alkali, potassium hydride, and it has to be aqueous. Let's put some water here. So it will give KBO2, that is potassium metaborate, and also give hydrogen gas. Correct? So this is my diborane. It reacts with alkali to give potassium metaborate and hydrogen gas. That's what I told, hydrogen gas and metaborate. You can balance this reaction. So you want, this has to be 2 potassium, right? This has to be 2 water molecule, and this will be 2. This will be 6. This is balanced out. Let's study more on diboranes now. This boron reacts with alkali metal hydrides to form metal tetrahydroborates or metal borohydrides. So this is the reaction. If you see, this is what it forms: LiBH4, NaBH4. So this is my borane, diborane. This reacts with metal hydrides, for example, sodium hydrides, to gives NaBH4. NaBH4 is nothing but you can say that this is borohydride, this is sodium borohydride, or you can say as sodium tetrahydroborates. These borohydride which we have got are very good reducing agents in organisms, and that's why we are reading this reaction, because these are very critical reducing agents. Boron also reacts with halogen to form iodiboranes, and the reaction will be B2S6. If you react with chlorine, it becomes B2H5Cl. This is the reaction. This is a replacement reaction actually. For example, this guy you have, right? So you have 4 hydrogen molecules. The moment you react with chlorine, 1 chlorine will replace the hydrogen. So this you get this kind of reaction. Boron also reacts with ammonia to give different products. For example, this is diborane B2S6, right? You react with ammonia, you get this compound. The moment you heat it further, you get this compound. So you get different products based on the amount of heat you apply. The boron also undergoes a cleavage reaction and to form adducts. What is adducts? adduct is nothing but two molecules they just combine. For example, in this case B2H6 and this guy, it reacted to form BS3 and NMe3. Similarly, B2H6 reacted with carbon monoxide, you get BS3 and CO. So it's an adduct. Adduct is nothing but two elements they just combine, right? So this diboron undergoes cleavage reactions with Lewis base. These are my Lewis base because they will donate electron pair, right? Lewis acids are nothing but the one which accepts electron pair, and the Lewis base is nothing but the one which donates electron pair. These guys, for example, carbon monoxide has extra electrons, right? Oxygen, if you see, so they are ready to donate electrons, and the diboron reacts only with, please note, Lewis bases, and it undergoes cleavage reaction because this guy is hungry. Is hungry. The boron is a hungry guy, and this guy is the feeder. This guy has extra electron. So hungry and feeder combined, they form the adduct. Right? This guy hungry, this guy is a feeder. They combine to form adducts. Correct. So let's talk about the preparation of diboron. We talked a lot about diboron. Let's talk about the preparation of diboron. So it is prepared by treating lithium aluminum hydride in diethyl ether. So this reaction we have covered sometime in the past itself. We have this BF3 boron trifluoride. You react with the lithium aluminum hydride with ether. You get B2S6. This is nothing but my diborane. This is the shape of the diborane. You must be familiar with the shape of diborane by now. In the lab, if you want to prepare this diborane, you can take this sodium borohydride and react with iodine, you get B2S. This is the lab preparation for diborane. In the industry, if you want, you have to prepare in the large scale. So what you can do is you can react this again this sodium borohydride. Instead of using lithium aluminum hydride, which is costly, you can use sodium hydride and use 450 Kelvin temperature. You will get this diborane. These are two different preparations for sodium lab preparation and the industrial preparation for diborane. Let's talk about the uses of diborane now. The first is it is used as rocket propellant. As I told in the initial slide, it is used for the rubber vulcanization, the P block element. So this is the boron, which is the diborane actually you can say, which is used for the rubber vulcanizer. It is also used as a catalyst to form hydrocarbon polymerization. You see the hydrocarbon forms a long chain using catenation, right? So this is used as a catalyst actually, diborane there. And it is also used as doping agent for semiconductors. In semiconductor, we need something called doping agent. You learn more about the doping agent in physics, where we talk about the semiconductor chapter. So this is used as a doping agent to create semiconductors. Let's talk about a different important compound of boron, that is boron trihalides. So if you see, these are my planar. If you see the structure of these are planar in structure, right? sp2 hybridization, all planar in structure, and they act as Lewis acid. Why? Because this guy is a electron hungry because it has only 6 electrons. This is electron hungry boron. So it acts as a Lewis acid. So it reacts with ammonia with a Lewis base to form this compound, right? And the reactivity series for this is BF3 is least reactive, and we talked about this because this is the back donation by fluorine to bromine, because fluorine gives electron to bromine and it becomes happy, and it is since it is happy, it doesn't behave as a strong Lewis acid. But Br3 bromine is not giving much electron. This is my bromine and bromine. So bromine is not giving much electron to boron. This boron is unhappy and it behaves as a good Lewis acid. So we discussed about this when we talk about the back bonding, right, or the electron donation. So if you have doubt, you can just watch that video in the same chapter where we talked about why the acidic character behave in this fashion. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.